Thank you, Amit. Thank you for establishing the requirement for low latency, transactional consistency, and real-time ingestion. And I will expand a little bit what Amit has already established, explain the nature of Bloomberg interaction with the market, right? And let me explain what the market is for Bloomberg. So for Bloomberg, every public, private company, all the exchanges in the world, regulatory banks, every government, federal, state, municipality, central banks, they are all market for Bloombergs. So anybody who either consumes or emits a financial data, that is Bloomberg market. So Bloomberg is constantly taking data from these institutions and giving back to the market. So it's in a constant interaction in the market. So it's a constant interflow. For example, it will take EPS or earning per share from a publicly disclosed company, either through newswire, their conference calls, or any other mechanism, and give back price to earning multiples to the market. It takes price from the market, like from the ticks or exchanges, and it will give back to the market market cap, enterprise value. And other thing is it will take, for example, estimates from brokers like your broker houses like JP Morgan or Goldman Sachs, and give back to the market consensus. As you can see, the Bloomberg is on both the sides. It has to take the data from the market, and it has to provide data to the market at the same time. So it is under pressure, constant pressure to ingest as fast as possible, and as well as provide it as fast as possible. And not only that, when these consumers, when they come back to us to get the data, we have to provide the data in a lightning speed. So this is the backdrop under which all Bloomberg systems work, regardless whether it's equity, fixed income, currencies, or anything. So all of the Bloomberg systems, they have that context in that pressure they are working. So with that, let me move to the data modeling. Before we move to the data modeling in HBase, let's review what we do in RDBMS, right? We have all seen pictures like this, and we know that this is a result of an elaborate process and tools being followed in RDBMS world, right? But the focus generally in RDBMS is storage efficiency, right? And in the HBase, we do not worry about the space, at least not that much, right? But at the same time, the process and tools which we learn are immensely important to us, because what they do, they make us, rather force us to understand our data. And without understanding our data, you cannot design effective data model irrespective of underlying technology. So I'll encourage all of you to, all the processes and tools which you have learned, continue to use that, right? Get the understanding of your data, and go ahead with whatever underlying technology you want to use for creating an effective data model, right? Right. So what we have in HBase for you to design your data model, we have these three components. Row key, which is very analogous to index in RDBMS. Column family, which does not exist in RDBMS. And columns, which sounds very similar to RDBMS, but in reality, it's very different than RDBMS, right? So besides these three components, we have another thing available to us in HBase, which is not available in RDBMS, which is distribution, right? So distribution is, or divide or conquer, whatever you want to call it, is a blessing for us, for software engineers, to solve large-scale problems, right? But it's important to understand how the distribution occurs, right? What is your distribution is. And you need to be in control of that distribution. If you're not in control, I think that blessing very quickly can become a curse, right? So you have to absolutely how your data is distributed. For example, if data is under-distributed, then you have case of hotspotting. All your reads and writes, either read or writes or both of them are going into the same node, and then you have not a scalable system. There could be a case of, in fact, even over-distribution, right? I mean, and I'll go on that case later. But what tools we have for you to be in control of the distribution, right? the first tool what you have at your disposal is, or mechanism you have at your disposal is, you can pre-split regions. Right? What does that mean, pre-splitting the regions? You can divide your entire key address space, right, depending on your cluster size and capacity, and that way your data is fairly distributed. Right? What does it gives you? It avoids hot spotting. It helps in mass onboarding the data, and it minimizes split after the deployment. Now, what I mean by minimizing split after deployment is once your system is commissioned, you can actually engineer it to not to have a split, or at least minimize, because when the split is occurring, I believe the system is at suboptimal performance level. Right? So this is how you control to have a good distribution, but if you have too much distribution, there is another problem. For example, for a rather simpler query, if you have to go to many, many nodes to serve that query, then the cost of splitting that query and all the RPC associated with it may not be worth it, and they might start eating in your performance. So keys should be distributed, there's no doubt it. But in my opinion, the related keys should not be distributed, right? So how do you control that? You identify what are the key components, what components of the key you want the distribution, right? And you use a split policy in HBase so that that distribution does not occur for that component. For example, in our case, we won't let IBM's data go in more than one region. So all data is in one node or one region. Right? Next thing, we're going to talk about the key design. I mean, write key is important. I mean, I cannot say enough about it, right? Everybody understands that, right? We have seen a system getting broken when you do not have a write key. But it's even more important in HBase. In RDBMS, at least you get more than one chance. You got one bad key, you can probably add another index. Yes, there is a cost to rebuild the database, other stuff, but at least you can add another key. But in RDBMS, you have only one key. If you got that key wrong, you pretty much have to drop the table, re-ingest it, and do the whole 9 yards again. Right? So it's very, very important. The keys are lexicographically sorted. They are just sequence of bytes. And unlike RDBMS, they don't have a definition. The key itself exists in the user space. The table itself, it's not part of the table definition. Right? Another thing which I suggest is that you design logical keys rather than a hash key, right? Because the logical keys allows you to, it preserves locality of data, right? You can apply predicates on keys component, and what I mean by that is like you can use like HBase filters, like row filters, and you can apply all those operations like less than, equal to, greater than, right? If you have only hash key, you can't really do that, right? And design small keys. I mean, the HBase literature is full of that saying why we should design small keys, and I'll try to explain it a little bit more later. Right? So next question is what should be in the key, right? If I have to speak in metaphors, then if you put purpose in your key, right, what is it for? Then success shall be yours, right? But what should be here, right? So data items that require predicates, those should go in the key. I mean, like same thing, you can use row filters, and you can even build filters where you can apply filters the components which are middle of the key, right? And depending on the query. And you can pretty much construct a SQL-like query like select this, blah, blah, and in the where clause. You can do that. You can pretty much model that, right? So data items that require atomic updates, those should not go in the key. Where they should go, we will talk about that later. Right? Next thing is column family and columns. Now we know that HBase doesn't demand schema. But we must specify the column families at the time of creation, right? Unlike RDBMS, the columns are not tied to the table, but they are tied to rows, right? And what does that mean? The column sets can be unique for each row. The column and the column families are named using ASCII characters. And unlike RDBMS, there is no name for the key. As I said earlier, the key totally exists in the user space. At the time of creation, you don't specify what my key is. Right? avoid long names for columns and column families. We'll go that also for later. Why is that the case? Right? So if you look at this column family and column names, basically they become part of the row key. Right? And if you look at the picture pointing out for HBase, the column family and column qualifier columns, they itself become the key, and it's associated with every value which you are going to store. So that means your key, if your key is small and your column family name and column qualifier are small, your overall payload, which is shuttling through your network, will be smaller. Right? Few more things about column family. It's basically a group of related data items, right? But let's reflect on that. What does that mean, grouping of related data items? But the question is, what is table then? Table is also the same, right? It is grouping of related data items, right? So if I look from that angle, HBase table is really it's a table of tables joined through one key, right? Related with one key. In my opinion, that's a very powerful concept to understand that, and I think it can help some of the problems which we think cannot be helped through the HBase, right? Now, each column family has its own storage file. That means, again, that's very powerful because that means you can control lots of properties at individual column family level, like what your block size is, what's the cache is, what's the data block encoding is. You can fine-tune at every column family depending on how you are using that column family. Right? How do you identify column families, right, in a given? So the easier case could be like all the business-related or particular business-related column data patterns can be one column family. If you do not have that case, then you can look size patterns, right? The data items which have similar sizes, they can be one column family. Or the queries pattern, the queries which are generally resulting similar amount of data or a larger amount of data, they can be a column family, right? So the question is, what should be columns? And in my opinion, data items which requires atomic updates or transactional behavior should be columns. Right? Last component of your logical key which you come up with, that can also be a column. Now you can ask, why are we doing all this? Right? What's the purpose of this? So remember, our objective was low latency, transaction consistency, and real-time ingestion. So HBase promises us low latency, but you have to back it up with right data model, and by data model I include the distribution and all other things. So once you have the right data model, you can get a low latency. Once you have a low latency, it's easier to have a real-time ingestion system. But what about the transactional consistency, right? That's what we are looking for. And you might say, all of us here know that this is a NoSQL database, non-ACID compliant database. That's what it is, right? But that's not entirely true about HBase, right? Because it does support some concept of ACID, right? And ACID, for folks who do not know, is for atomicity, consistency, isolation, and durability, right? Atomicity, like either an operation completely succeeds or fails. To give an example, let's say we have a columns A, B, C, and all of their value is 0, and you apply an update A equals to 1, B equals to 1, C equals to 1. So if the operation fails, it's guaranteed to be equals to 0, B equals to 0, and C equals to 0. If it's successful, it's guaranteed to be A equals to 1, B equals to 1, C equals to 1, and not any other combination, right? That's what's guaranteed. Consistency means like, okay, once a update is successful, all the read clients should be able to see that value. And HBase very easily achieves that because a given row key is served by a single region server. Right? Isolation means two operations do not interfere with each other. And to give an example, let's say there are two updates going on, A equals to 1, B equals to 1, C equals to 1, and A equals to 2, B equals to 2, and C equals to 2. At the end of these two operations, which are going concurrently, the values are guaranteed either A equals to 1, B equals to 1, C equals to 1, or A equals to 2, B equals to 2, and C equals to 2, and not any other combination of, right? Durability is easy to understand. Once a mutation is reported successful, it should not be lost, even after system crash. And we know that HBase provides that. And HBase provides all this property at row level. Right? So that means if we design our data model such that we can take advantage of the atomicity of the at row level, that means you've designed a data model which can give us a transactional consistency. And that's what we have done in our case. Right? In the next few slides, I'm going to show some illustration which will basically highlight what I have talked so far. Right? Right? If you look at this picture, right, the RDBMS is basically says unlimited number of columns and fixed number of columns. But on HBase side, you have unlimited number of rows, varying and unlimited number of columns. And I'll say that it's not only varying and unlimited number of columns. In fact, each row can have a distinct set of columns. That itself is a huge. In this illustration, what I'm trying to show is a simple transpose of an RDBMS relation to an HBase. And at the end of it, you will have a row which will show a transaction consistency either both in RDBMS and as well in HBase, right? In the RDBMS case, you have a table with a dimension D1 through Dn and columns C1 through Cn. And once you transpose that row key as D1 plus D2 plus Dn, you have a transactional consistency row in both the systems. This is our simple data flow architecture. There are various sources through which we are getting the data. The first transformation is basically applying the business rule, make it available for the distribution. And the second transformation is pretty much for catered to the particular storage type, right? And once we have that taken care of, we have a middleware through which we are making the data available to the terminal, and in the end we have a happy client. Next slide is like how our ingestion or streaming task architecture is. It's basically taking a group of messages from the queue cluster and then breaking that into further groups and providing that to a updaters thread. Updaters threads are applying read, modify, and update paradigm. And meanwhile, the retriever is waiting for the acknowledge from the updaters. And as the updates are getting successful, it will send to the retriever acknowledgement. Only if and only if all the acts are received, the retriever task is going to send an acknowledgement to the queue cluster, and then we will go and read and process the next batch. Right? So that's our streaming task architecture. Thank you. Of course, we are hiring, and right, and we are ready for any questions you have.
How many columns are
So there are the HBase literature has different numbers quoting, right? HBase literature says whatever stats are quoted by big table, Google's big table, you can divide by 10 and have that, right? So Google's big table says we can support hundreds of column family. So that means we can have 10, right? But then somewhere also I read that because of some compaction issues or some other things, it is advisable to not to have more than 2 or 3 column families. But I think if we make that use case more popular, I think community can work together to have that problem solved. That's what I think about it. But I think it's a powerful tool.
So you guys mentioned in one of the architecture diagram that if one of the region is down, like you guys have to, the zookeeper takes care of it and add the new region, and then client has to attach to
No. So what happens is when one of your region server goes down, so the ephemeral node from zookeeper is deleted, and then master basically sees that the zookeeper is not, the region server is not listed anymore in the zookeeper. It issues a shutdown hook to the region server, which means basically if it is stuck in a zombie prostate or something like that, we have seen that with long GC pauses where it does not heartbeat it to zookeeper, and the master thinks that, and then the ephemeral node is deleted after the timeout, and master issues a shutdown hook to the region server. In that case, it basically kills itself, all the regions are closed now, and then master starts the recovery process where it takes the regions, transitions them to the new region server, it opens the wall file again, does the region split, the log recovery and all that, and finally regions are brought up all right on other region servers. So So that one thing is with that is it basically breaks your data locality because your data was local on that particular node, and that can be fixed after later on with major compaction.
So I was curious to know how much on an average the downtime is, how often?
So it depends on number of regions on your region server. So what we have seen, it can go up to like, if you have 5 to 6 seconds, what we have seen in our case, but it can go up to like a minute, depending. So we saw that with like we were testing something, and we have thousands of regions on one of the region server. That takes longer, and the client has to refresh the meta after that. That's on the client side. It's not automatically.
So how do you handle the problem with having a single row key when you would traditionally in RDBMS might need to have 15 indexes to support all your access patterns?
I think, so when you have 15 indexes, you have to think about what problem you're solving, right? So when you have 15 indexes, in generally what you're trying to do is you're trying to solve a data integrity, right? That's what I have seen, right? Just trying to solve a data integrity problem, right? In big data world, what I have seen is the responsibility of data integrity is shifted to the application, right? So I don't think you have a replacement for the 15 indexes, but to take care of that data integrity in the application code. And on the database side, you basically, at the most, using one index, you can solve one or two use cases.
I mean, some of the different approaches that we've tried is like either put the relationships in a graph model and then point to the row key, or put the stuff in Solar or Elastic and point to the row key.
Yeah, those
or
are
replicate
different
the data
technologies,
and
yes.
have like 15 row keys with the data replicated. So, but I want to know if there's a better solution or what is your preferred solution?
Do you want to take it offline and just in the hallway?
Very good. Thank you, guys.
No more questions. We got to start with the next one.
We can talk.
But find the person in the hallway.
Thank you, guys.